back for another 7 Caillou challenge. This one's called Sum of a Beach. Beaches are filled with sand, water, fish, and sun. Given a string, calculate how many times these words appear without overlapping, regardless of the case. This is a nice short description. It's very clear what they want from us, so these make great examples to work out and to try to explain. Notice the examples they provide. Water slide hits because the word water appears in it, but none of the others do, so it should return 1. Golden sandy, water, beach. So you can see sand hit, water hit, and sun hit. That's why it's a 3. Here we had fish, sun, fish, which made 4, and city, town, car. Show doesn't have any of those words, so it returns 0. So I think that's pretty clear. Why don't you go ahead and pause the video, give this one an honest attempt, and come on back with when you're ready. We're going to go over a few solutions. We're going to roll our own sort of speak first, and then I can show you how to use some built-in library methods that handle this sort of work and make things easy. But it's really important that we can come up with these solutions on our own first, and I think it gives you a greater appreciation for the built-in features in C#. So I assume you had your chance to work on this. Let's get into a solution. I'm actually going to make a little helper class for this. What beginners tend to do is they tend to put all the logic into one sort of monolithic function. And I like this example for sort of breaking out of that thinking. Classes are your friend. When you first start, people are intimidated by them. They don't want to break out and make something new. But that's exactly what we're going to do here. So we won't mess with their class. This is used for Code Wars, for testing the solution. But I'm going to add another class. And public, we use the class keyword. Public's just an access modifier. We make it public so it can be accessed by anyone, which is what we want here. I suppose I could make the class internal to this Kata class. You could also do that as well. We could embed it privately in here. When you make these decisions in the real world, it's a matter of where you want accessibility. Typically if people don't need to know, then you hide stuff. That's sort of the general rule. You want the fancy term for that in computer science is encapsulation. We kind of hide the implementation details of our designs. And we're not being sneaky, right? You don't want to overexpose things. You can get into trouble. People misuse things if you give them access to your data, not even necessarily intentionally. Accidents happen. So imagine a control system with a bunch of levers versus one with only just a few. Clearly, the latter is much easier to operate. And so that's why we make our classes, the public interface of our classes, we strive to make those very simple as well. We don't want to have someone have to read an instruction manual just to use our classes. So anyways, with that said, I called my class search word. And the idea is that I'm going to create one of these objects for each of these texts that they provided us: sand, water, fish, and sun. And so the first thing I want you to think of with a class is we're going to implement a constructor, and that just tells C# how to construct objects of your custom type. So the way to do that is you say public, and then you just use the name of the class, which in this case is search word. And then you can pass in parameters like you would with a method. Here we'll take in a string, right? Because we want it to hold sand, water, fish, and sun. So I'm doing it that way. And then the idea with the constructor is this gets fired off right away. You can think of it like a method that happens right when we create objects. And so we can initialize properties of this search word. So let's think about what that could look like. What are the aspects of search word? How are we going to be checking if these words occur? So I came up with some private fields to use. Of course, we want to save the text involved, right? The word that was passed in. You could name it word. I called it text here. However, whatever makes sense to you. I'm going to create an integer that I'm calling index, or maybe you want to call this letter index, but it's basically going to point to whatever point in the word we're working on. So imagine we're going to start for S. We're going to look for S first, and if that hits, we're going to check if A is next, and then an N, and then a D. So this index will start at 0, and then 1, 2, 3, all the way to the end of the word, right? ideally we're matching at some point and finding complete word matches. So I called mine index. Feel free to name yours as you like. Just make sure you use your name. And then finally, I'm going to make a Boolean variable that I'm going to call active. And this is just going to denote whether the word is actively hitting for letters or not. So like imagine as we processed this golden, nothing's hitting, Golden, nothing's, I'm not active yet. And then all of a sudden I hit an S, right? I have two words that start with S, sand and sun. They would sort of flip this to active in that state. And then they're sort of requiring that the next character match the remaining letters in their texts. So that's sort of the purpose of that field. And then, so now that I have this data, in fact, I'm sorry, I shouldn't have initialized text here. We'll do it in the constructor. I can say text is equal to word, and this is just going to save, make a reference to that word that was passed in. Index, of course, should start at 0. We want to check from the beginning of the word, and we'll assume active is false to start. So we have a way to make these objects, and my sort of strategy with this is I want to make a method for search words where you basically feed it a character and it processes it in turn. So to that end, I'm going to make it public because I want search word objects to be able to invoke this method. So I'll say public. I'm saying void because it's not going to return anything. It's going to sort of update my state variables here internally to the class. That's why I'm returning void. And I'm just going to say feed char, or you could call it feed letter. Basically you're giving some kind of input, letter input, one at a time. And I'll put char c, and then we'll make a method body here, enclosed in curly braces. And then let's think about like how we want to process characters, right? A lot of times we sort of boil this down to just a couple states, right? So you might, and there's multiple ways to do this. If you came up with a different way of or order of processing, that's fine. But you could imagine we have something like, if the word is actively hitting for letters or if it's not, right? And we do different things in each case. So we'll kind of break that down and think about that. So if it is active, that means we hit, let's say, just the first letter that flips active, and it's like, okay, we're requiring at this point that all characters continue to match, or we're going to sort of bail out and say this is not a match. So if we're active, let's check, right? So if C is equal to the text at the index value, right? In that case, we're actively processing. That means we hit another match here, right? So each time we match a character with a letter in the word, we sort of want to update this index, right? Otherwise, it'll just keep being stuck at the first letter in the word, right? It would just always look for S's, and that clearly wouldn't do what we want it to do. And then, if we're hitting, it's going to stay in this little section right here. It's going to keep coming through and hitting this section every time we feed a character in. And so eventually we have to check if index is equal to the length of the text, right? That means we completed the word, we searched through. We don't want to keep scanning at this point. The word has been found. We want to reset and see if the word occurs again. So in this case, and let's make a little field for this too. We'll call it match count, where we're just going to keep track of how many times this particular word hits. And I'm going to introduce you to something that, maybe I haven't used at these lower Caillou levels at 7 Caillou, but it's good to hear about. And if you just want to make this a regular data field, go ahead. I'm going to use the idea of a C# property here. And so if this is new to you, feel free to look into this. It's definitely something worth your while to read about. In a way, it's like a data field, but I just want you to think that it's got some sort of built-in functionality here. I'll write it out first so you can see it. And you basically get these getters and setters with it. So instead of the person getting the data automatically, I actually get a chance here to say, whoa, hey, you can get whatever you want. You can read this value. But if you want to modify this value, no, we can only do that within the search word class. That's what private means. I don't have to have the private here, but That would sort of defeat the purpose. I don't want people up here in sum of a beach modifying the match count value, right? And I know you'd probably think, well, nobody's going to do that. Well, it happens accidentally in real life, more often than you may think. And so this is just a sort of protection for us. And imagine this is your job up here. Like, you clearly don't want to change the match counts. You just want a report from each search word, how many times it hit for the given input string, right? So hopefully that's clear. But if you want to just make it like these ones and not use these curly braces with get set, you can do it that way too. It's going to be fine. But I do want to challenge you to get used to properties. You are going to see them a lot in C#, so don't be intimidated by that. It's just got some sort of under the hood methods to access and give you a little control about a little control over how your data is accessed for your class. So that said, we have this match count right now. And what I'll do is when we index hit the end of the word, that means we completed it, right? Let's increment that. Let's increment match count. And then I'm going to make us a helper method. We don't need it. It might be a little bit overkill here, but I want to really get you thinking about how to make proper classes. So I'm going to make a reset method to this end. In fact, I'll put it above my fields. We'll say private. Again, I only want this method to fire internally. I wouldn't want somebody outside of the search word class to be able to reset it and clear all my data, right? So public void reset, and all it needs to do is just say the index goes back to 0 and active goes to false. I don't want to clear the text, right? Because this search word object, it's going to always look for sand, right? Sand may occur multiple times in the input string. So I don't want to clear out the text, save that, but we want to say, hey, we're starting from the beginning again and we're not active. Okay, good. So after that, we can just invoke our reset method here. Again, you could have just put the body of the reset, these two lines right under match count. If you like that better, go ahead. Okay, so we covered that case. This was if the character matched, right? And so that's good that we have a way to make search word matches, right? But it's not always going to work that way. So let's handle the case when it doesn't. This would be like we're actively processing. We've hit at least one letter match already. But what happens if you get, S-A and then R? We need a way to bail out. That's going to happen clearly sometimes. So the else clause represents when C is not equal to the letter that it should be equal to. So in that case, you may be thinking, well, easy, just reset. But I want to make you think about an oddball case. So imagine this. Imagine the case you had a word like S-A-S-A-N, right? And so you're processing, you hit an S, good. A, okay, yep, we're still hitting for sand. And then you get to S here. If you're not careful, and maybe you ran into this when you were doing it on your own, you're going to see that it's a mismatch. And if you just say it's not a match and start over, you could miss that this missed letter was actually the start of a full sand that was coming. You don't want to just bypass that, right? You don't want to say, okay, this S wasn't a match, I'm going to start at A now, because then you'll miss that sand. So what I'm going to do here is I'm going to say, if the character happens to equal the first letter in the word, so, like this S is equal to this, all the inputs can be lowercase, so we don't have to worry about case sensitivity here. If that's the case, let's just consider ourselves still active, and we're going to just look at the second letter. We're going to just, it's not a reset, right? We're just starting from having the first letter match again. And then otherwise, we'll say reset. So if you came into some problems with the tests, maybe that was one thing that you kind of failed to address. Very easy to overlook, don't sweat it. You know what? I should probably get out and expand my screen a little bit for you. Okay, good. I think this covers us in the case where we're active. Now, if you look down to this else, this would be if there's no active searching right now, meaning we've just been fed a bunch of letters that don't that don't start the word we're looking for. So in this case, we basically got to handle when that match finally first happens, right? And make sure we set it to active. So if the character, if we find a match, let's set active to true. And let's bump our increment, or I'm sorry, our increment, our index value up, so it's moves on from the first letter. And I think that's all we really have to do there. Of course, we'll test this and see if we got it. But something like this is what I'm going to use. You can see not a terribly big class. You don't want your classes to be big. But this prevents us from trying to implement all of this in the sum of a beach method, which can be nice. So let's go back there and start working with our class, right? So now what I can do is I can make a collection of these search words. That's the class I made. So I'm going to make a list of my custom object. I'll call it search words. You could call it just words. And this new syntax we're just going to use to set up a brand new list. A list is just, you can think of it like a generic collection of objects. They're nice because they can change in size. You may be familiar with arrays, which have a static size. You sort of initialize them to a certain size, and they're kind of stuck there. With the list, it can grow. So I'll do that. Of course, for this example, we know there's only 4, so we could have done it as an array, but with this list implementation, you could, in theory, add more words. So I'll add these in. And then remember, when we want to create a new object, we use this new keyword. And if you remember, for our constructor, it just takes the word in that you want it to be. I'm going to use all lowercase since that was part of the description. That case doesn't matter. And you can sort of copy this line a few times. Normally, we wouldn't do this in a program. You'd probably read these values out of some kind of configuration file. But for this simple example here, for Code Wars, this is just fine. And it was sun. Okay, so I made this search words list, and then list has an add method that allows you to put things in it. So I put in sand, I put in water, I put in fish, and I put in sun. Now, I didn't just put in the text, right? Like, these are actual search words. They're smarter than just dumb text. They have feed char, and they've got these properties. It maintains a match count that I can check at the end to get our word hit count, So good, we have that set up. Now what we could do is we could sort of iterate over the input string S here. Let's do that. So I'm going to use a for each loop for this, and I'm going to say for each character, which I'll give a name C, call it whatever you want, in S. And then what I'm going to do here is say S to lower. String has a to lower method. You can check the docs if you don't believe me. It just converts all uppercase values to lowercase. So that's all we're doing there. We're going to step over each character at a time. And now what I can do is, with each character, basically I want to feed each character, I want to feed the particular character I'm on to each search word, right? So then I can nest a for loop in here. I could say int I equals 0, I is less than search words.count plus I, right? We're just going over each element in the collection. And I can say search words at position I, feed char C, right? And so that's going to feed the input letter to each one of these. And then it does its magic, right? Because feed char is sort of the brains of this, right? It's going to scan and update its state. And the idea is that it's going to go through every character in the input string. And then finally, we're going to return a count. And hopefully you can see the count is just going to be, we add up the match count for each search word. And I can access that because I left this, I didn't make this private, so it's accessible here. If I had said private, it would not let me access that here. So anyways, after we're done sort of populating our search, feeding our search words, if you will, we could do something like, you can go over the collection of var word. Now this var is just a handy shorthand, like you can think of it as a variable. I could also say for each search word word in search words. And then we're going to say, we can make a little variable here. We could say int num hits equals 0. And then what we can do is say num hits plus equals word dot match count, right? And then finally, after that's done, we simply return num hits. Now, I'm going to give you some, like I said, we'll go over some library stuff too, but this is just supposed to represent us implementing this problem ourselves, which is very good to know. Like, you should always be able to do that. So let's see, I probably did something stupid, but that's why we test, and it's going to yell at me, and I probably didn't bring in any using. Yeah, so good, let's do this. The type or namespace list could not be found. And it's very nice, it says, are you missing a using directive? I most certainly am. If you wanted to go look up C# lists, that should be, or if you've done my other videos, using system collections generic, I think will cover us. Let's try that and see if the error goes away. Okay, good. So we passed all the simple tests. I guess I didn't mistype anything. But of course, I have a lot more tests. They ran these basic tests, these 4 down here, and it looks like we did that just fine. We'll hit the attempt. Hopefully everything's still green. Good. So you could fire off and submit here if you wanted. If you're not interested in the sort of advanced part where I show you some library shortcuts, you could tap out at this point. I encourage you to stick around and check the rest out. We'll just, there's some built-in features for searching for words that we'll go over. And then even this little thing at the end, right? Like I could show you a way to sort of sum up all the values in search words without doing it as a loop. I don't want you to think that there's anything magic here when I use these library methods. They're basically doing the same thing under the hood, but it's a sort of a syntactic sugar, if you will, that allows us a shorthand for typing some of these things. Common things that people shouldn't have to recreate all the time. So to that end, I'm going to use a link method. So before I get yelled at, I'm going to say using system link. And we're going to use this, I've told you in the past to just keep sort of like this page open with all these enumerable methods in there. There's so many handy ones. We're going to look at this aggregate one that sort of does what it sounds like. It's more general than add, and you can think of it as an adder. Maybe that's the most common use of it, but they call it aggregate for more general purpose. You could multiply all the values, or you could combine text, or however you want to sort of accumulate values. And so they have a nice example here. This one's with integers. That's what we're working with, right? Match counts were integers, but you can see they have other examples here with strings, and there was another example higher, I thought. Yeah, something here with a little string fruits collection, but this one's the most relevant to what we're doing. So also, I know it's a little weird at first, but also I want you to know is that they give you this kind of seed value, this, think of it like the running total, right? We typically don't run into this when we're using the link methods. Normally we just give a variable name for each item in the collection. And that's still here, that's part of this list. This is the parameters list. So this is like the shorthand of a function that we've been kind of talking about, lambda functions, you know what I mean? Where you get the parameter list, you can have more than one parameter in a method, right? Then you got this arrow thing that sort of denotes the body of the methods coming in, then this is the body. And so the 0 is just saying, hey, we want to start from 0. You can add from a different number. Most of the time you probably add from 0, but you don't have to. So that's nice, they give us that flexibility. And then this total, this first parameter will sort of follow, it'll be initialized to 0, and then it'll move based on what you do in the body of your method. And then next here would refer to each item in the ints. This sort of second parameter is going to just be populated with each item 4, then 8, then 8, then 3. So this is really good for what we want to do. So if you want to get a little more fancy with it, like I said, we didn't have to write those 3 lines or whatever it was, you could simply say return search words, right? Do you remember fruits? It was called, you invoke the method on the collection, right? So they have a collection of ints, so they called ints aggregate, and then we'll go into it. Aggregate. I want to start my adding from 0, just like we did here with num hits, right? I won't need that anymore, so I'll get rid of that. Aggregate 0, a comma, and then we go into our lambda expression, right? It's going to have 2 parameters. I'm going to give it, I'll use total just like they did, and then give a name for your parameter for each item in search words. I think an appropriate one would be word or search word, but you can call it banana if you want, you know, they're just variable names. But remember, we're trying to make life easy for ourselves and the people who come after us, and ourselves when we come back 6 months, a year later, and we're trying to figure out what the heck we were doing before. And then simply we can say for each word, right, we're going to add that total. We're going to add the word's match count to that total, something like this. So let's see if I think I need another closing parenthesis here. No. Sorry, my eyes are playing tricks on me. But if you're not sure, just hit test. Let's see. Test worked. I'll hit attempt. But yeah, so we trimmed up the body a little bit, whatever you think that's worth. When you work with these a lot, though, you'll just start thinking this way and just type it out again. But under the hood, this is still kind of looping over the search words collection, similar to what we did before. It's just a condensed way, a way to condense your code, and it's comfortable when you use it for a while. Now, to the key point though is this idea of searching for words in text. You can imagine is very common in computer programming. So what we could have done instead of this search word thing, just so you know, we have this concept of something called regular expressions. And you should look at regular expressions, excuse me. They can be complicated for beginners. There's a lot to digest at times. But they offer us a way to search. So, again, before I get yelled at, we'll go and bring in the using system text regular expressions. If you Google regular expressions C#, it should take you to a page describing this. And then you can do something like int, let's say count1 equals regex. That's the name of the class. It's short for regular expressions. It's got this matches method where you can give it an input, which was just our input string to lower. Remember, we're not case sensitive for this challenge. And then whatever word you want to search for. So sand, right? And you could repeat something like this. Let's see. And you could do all the words this way. What were they? Water, fish, and sun. Of course, I better give my variables different names. And I'm just showing you that there's another way to do this. And then finally, you could just say return count1 plus count2. Okay, so just to show you that regular expressions do this too. Let's try this. We're not even using our class anymore. Cannot implicitly convert type system type regular match collection to int. Okay, oh, right. So these would produce some kind of match object and this a collection of matches, I should say, and it's going to have a count property just like lists and other collections do. So to get the count, we gotta do that. So test. Attempt to make sure this is the real deal. And yeah, and so you could have just added all of these statements together. You didn't even need to create count 1, count 2, count 3, count 4. You you could just say this plus this second line plus the third line plus the fourth line. You could fit it all on one line and get one of the famous one-liners. I'll leave it up to you which version you want to submit, but you can see this challenge could be done pretty quickly. One thing to note is with this version, we're sort of going over the string 4 times, right? Whereas when I did my example, I just wanted, I grabbed each character once and sent them to all of the words in my search words collection. So I only went over the input string once. So in a challenge this size, it's not going to matter, but it's just something to keep in mind as you're selecting which path you want to go on. You know, sometimes it can be expensive to go over a collection 4 times. And remember, you might have more than 4 words in real life, right? What happens if you have a million words or whatever? So I'll probably just, since I went to the trouble of creating the class, I'll probably just return that. Maybe it's helpful to other people, you know, even though I'd agree it, you know, people will rightly criticize me for being verbose, but that's okay. I don't mind being teased for that. This is a learning channel, so hopefully you remember search word. And the important part is really this is meant to help you attack more significant problems than this and teach you how to make classes. So worth the trouble. You're going to want to get comfortable with doing that. And maybe I can get rid of the using sense. No more. Yeah, I think I covered that well enough. I will go back. They're going to make us reattempt because we modified the code. That's fair. And I'll go ahead and submit mine like this. And then, yeah, well, maybe it'll, but yeah, you can see, look at this, how nice and clean they did this. Rejects matches, input to lower. They did it all in one shot, right? You can see they're using this kind of, this bar character here must be some kind of delimiter that gives it different words to match with. Again, consult the regular expressions page for that. And I have other challenges on that. So, and you know where to find me if you have questions, right? We can do more of that. So yeah, see what else you can learn from other people. Nice ducky there. And otherwise, I will see you in another video. As usual, I appreciate you watching. Thanks so much for the subs and likes. You guys keep me going. Thank you. See you in another one.